In the design of the computer system, we need to store our information, for which we need a storage unit. Why don't we use one of these storage unit as our storage device, the memory system? Why do we need these many different types of storage units now to construct a memory system for the computer system? Let us check out the reason. CPU is the king of the entire computer system in the consideration of the speeds. It is the fastest device which has the best read and write speeds. It can read in instructions from any unit and it can write instructions to any unit in a much faster rate than any other device in the computer system. Let us compare the speeds of CPU with these storage devices. Starting with the secondary memory. The CPU is going to have its read and write speed something like 100 instructions per unit interval of time. It can read and write 100 instructions in 1 unit interval of time. And coming to the speeds of secondary memory would be something like 10 instructions per 1 unit interval of time. So if CPU requests for 100 instructions to the secondary memory can provide only 10 instructions to the CPU, and CPU executes these 10 instructions just in 0.1 interval of time, and the CPU is going to be in the idle state for 0.9 interval of time waiting for the next instruction to be provided by the secondary memory. So here the system performance is going to be very low. Here, CPU executing only 10 instructions and sitting idle for 0.9 intervals of time. You can decide the system performance with respect to the number of instructions executed. More the instructions the CPU executes, the best is the performance. So here the speeds are very low with respect to the secondary memory. However, the secondary memories are available in huge in size and very low in cost. Something like 100 GB secondary memory is going to cost us $50. However, the performance is very poor. Coming to the main memory. The main memory is going to have something good speeds, like 60 instructions per 1 unit interval of time. CPU executes these 60 instructions just in 0.6 interval of time, and it's going to wait for 0.4 intervals of time for the next instructions. The performance is good, however, delay time is somewhat not acceptable. Memory devices are going to be available in less in size, but are costlier than the secondary memory. The example would be something like 1 GB of RAM is going to cost us $50. If we want to construct 100 GB of main memory, it is going to cost us about $5,000, which is too costlier. However, the performance is good compared to that of the secondary memory. Coming to the cache memory. Cache memory chips have the greatest speeds than any of the storage units. It's going to be something like 90 instructions per 1 interval of time. So the CPU is going to be in a busy state executing all these 90 instructions for about 0.9 intervals of time and will be in the idle state just for 0.1 intervals of time. This is going to be the best read and write speeds that the CPU is expected to have. However, the cache is going to be available in very less in size, small in capacity, and huge in cost. It could be like 1 MB cache is going to cost us nearly $50. So you can expect 1 GB cache is going to cost us thousands of dollars. Hundreds of GB of cache memory is going to cost us millions of dollars, which would be too much cost oriented, and no manufacturer will dare enough to design a computer system containing such huge cost of memory devices for the performance sake, and there won't be customers to purchase such a device too. However, this cache memory is going to provide us the best performance than any other storage units. So considering the speeds and their capacities and the cost of construction of the computer system, the manufacturers consider all these 3 memory devices as one memory unit, and they organized all these 3 memory units as hierarchical structure according to their speeds and sizes. The device which is much faster is placed near to the CPU, that is at the cache. The next level is the main memory, and the next is secondary memory. In order to get an optimal performance, not the best, not the worst, but an optimal average performance with a very less amount of cost. Now let us check out how these units are going to communicate with one another. On the left hand side we can see the figure. This is how the basic structure, how these units are placed on a chip. This is our CPU. Very near to the CPU the cache chips are available, and the next the RAM slots are available, and to this board the secondary memory devices are connected with the buses. Let us now check out how these devices are going to communicate with one another. Whenever CPU needs an instruction or a data item, it checks for the first time from the fastest device, that is the cache memory. If the instruction is found, the cache memory provides it to the CPU and the CPU executes the instructions. In case the requested instruction is not present with the CPU, the cache memory, CPU checks out in the main memory, and the main memory provides the instruction, one copy to the CPU and the other copy to the cache memory, which could be useful in the further future use. So in case if CPU needs the same instruction to be executed in the next coming levels, then the CPU checks for the instruction in the cache and immediately gets the instructions and executes it. The requested instruction, in case if it is not available both in cache and main memory, it could request the secondary memory. The secondary memory could provide the instruction to the main memory, and the main memory provides the copies to cache and as well as CPU. Now the CPU is going to execute the respective instruction and provides the partial results to the cache memory. The updated results are going to be saved from the cache memory to the main memory, and from main memory the results are stored permanent in the secondary memory or are sent to the respective output device unit. This is how the CPU and the respective memory units are going to communicate with one another. Hope you have thoroughly understood about the functionality of the CPU, the I/O unit and the organization of the memory unit. In the next coming lecture, we are going to see about what exactly a software is and what are the different types of softwares available.